a joint walkthrough through JFrog demo environment. So let me just check. Here we go. All right, now you should see my screen and my slides, and everything should work. This is me. My name is Baruch Sadogursky. I'm head of developer relations with JFrog. At JBaruch on Twitter. Feel free to follow me and continue the conversation if you have any questions or whatever. So what we're going to do today is we're going to speak just a little bit about what JFrog Artifactory is, what JFrog X-Ray is, and then we will go through the trial, through the demo together. We will create an application file. We'll use Java for this example, but you will get the essence of how it works for any other programming language. And then we'll create a base Docker image from one of the base images available on the internet, and eventually create a product Docker image. Well, we will kind of containerize our application file inside a custom Docker image. So before we start, talk about it, I would like you all to go to try.jfrog.com and spin up your trial. It will take about 5 minutes for your trial to start, and in the meanwhile, we will talk a little bit about what you should expect today. While you are doing this, let me start with a couple of housekeeping items. So you probably noticed that you are all on mute, and that's of course to ensure the audio quality of the webinar. There are obviously ways to communicate with us. There is a chat, and I see that some of the people already post there. There is a comment that the sound is low. If that's what you experience as well, please let us know in the chat, and we will fix that. And more important, in the chat there is a Q&A panel. So if you click on the Q&A button, you will see a panel where you can ask questions. Towards the end of the webinar, I will try and take as many questions as possible. So as we go, if you have any questions, please use the Q&A. Please use the Q&A panel for that. This webinar is recorded and actually streamed live now at our JFrog YouTube channel. So you can, after the webinar, you will have it already available, so you can share it with your colleagues and friends and your boss. So that is will be available immediately. So I think that's pretty much it. I hope you all actually start your demo environment now at try.jfrog.com. And while this is happening, and as I mentioned, it will take a couple of minutes, let's start with the basics. So in order for me to gauge the level of explanations to the audience, I will run a little poll by you, and we will mostly show you two products today, JFrog Artifactory and JFrog X-Ray, and it will be very helpful if you would help me understand what is your familiarity with two products. There is a question about Artifactory, question about X-Ray, so feel free to vote. We will wait a minute to get kind of at least a good number of votes, and based on what I see, we will continue. Well, okay, the crowd is kind of all over the place. There are some people that less familiar with Artifactory, more familiar with Artifactory. Almost no one have any knowledge of X-Ray, so that's good. You are in a good place. We are going to talk about X-Ray, and we will fix your lack of knowledge, obviously. So thank you for that. and now I kind of know what to do. Okay, so let's start with introduction. What are JFrog Artifactory and X-Ray? And I will show you a diagram that explains the place of all JFrog products in the ecosystem of software development, and we will talk about where Artifactory and X-Ray fits. So we obviously start with development team that write code. And while they write code, they use various package managers and declare their dependencies and use operating system level dependencies and what's not in any of the tools that you can see here on the slide, and much more. So if you have a Java background, you will use stuff like Maven and Gradle. If you write Go, you will now use Go modules. If you write JavaScript, stuff like NPM, Python, Ruby, whatever you use, you will use some kind of package management inside, RPM, Debian, Docker, Helm, you name it. All of them have kind of a way to declare the dependencies. And when you're done with this piece of code that you are working on, you will run a local build. This local build will require the dependencies that you just asked to bring, and they will actually fetch to a remote repository or remote registry to get those dependencies. And this remote repository or registry is JFrog Artifactory, your in-house universal artifact repository. As you can see in the graphic, it's going to be installed on-prem or in the cloud, so whatever you prefer. And the dependencies will or won't be found in Artifactory. If those dependencies are completely new, they won't be found in Artifactory, and Artifactory will know how to go to remote repositories and bring those artifacts from those repositories and or registries. And once those artifacts are brought from those remote locations, JFrog X-Ray kind of kicks in and starts scanning those artifacts. It can scan those artifacts for whatever metrics you care about, mostly, and out of the box, it will be security, vulnerabilities, and licenses, open source licenses that they have. Again, as you can see here, JFrog X can be on-prem, can be in the cloud, whatever way you prefer, and those artifacts will be then scanned for any threats and returned to those package tools, package managers that require them. After this build was successful, development team as a next step commits those changes, those declarations, and package configurations into version control system, and this is when CI servers kick in. And whatever CI server you use Jenkins, you use Jenkins X, you use Travis, Drone.io, Circle CI in the cloud, or stuff like TFS, VSTS, Bamboo, whatever build tool you use, CI server you use, those CI servers do exactly what the developers just did on their machines. They run the same build using the same build tools, using the same package and dependency managers. And those tools will require the same dependencies that we spoke about. They will fetch it again from Artifactory with a slight change. Now, this time, everything will guaranteed to work because those dependencies, those packages are already pre-cached in Artifactory, so the retrieval will be successful every time. And once those artifacts are returned back to the CI servers, the product that CI server built will be created, and this product will be deployed. Those artifacts will be deployed to Artifactory. With them, another piece of software will be deployed, and that's what we call the build info bill of materials. This is a metadata. This is a kind of information about the build that will be collected in the CI server. And this information will include stuff like which artifacts were created and which dependencies were used, which environment variables were in effect during the build, etc., etc. All this information is gathered through various of different tactics depending on the CI server, on the build tool. It can be a plugin for a CI server, like Artifactory plugin for Jenkins. It can be a plugin to the build tool, like Artifactory Gradle plugin and Artifactory Maven plugin, or it can be collected by a JFrog command line agent that is used in the CI server to build the software. Either way, using one of those methods, eventually we will get as much metadata as possible about our artifacts, and sorry about that, all of them will be deployed to Artifactory. Now, when we have already in Artifactory our command, our artifacts with all the metadata, a pipeline kicks in, continuous integration and delivery pipeline kicks in. Different tools for quality assurance, quality control, start to check the artifacts that we created and verify that they pass various quality gates because they are good enough to be promoted further and further. There are stress tests, there are specification tests, they are quality tests, and artifacts are promoted from one repository to another through those quality gates that we are talking about. Once they are ready to be deployed, they are deployed to production if we are talking about deployable software. Deployable software is the software that is deployed on your servers, and then you use tools like Chef and Puppet and obviously Docker and Kubernetes to roll out the new changes to your servers which are in your control. Another type of software is a downloadable software, is the software that you distribute to other third-party people, machines, or devices, and they go out for external distribution. And for that we have JFrog X-Ray, which is a distribution hub in the cloud, or JFrog Distribution, which is a distribution hub for on-prem in-house distribution. And if you use JFrog Distribution, from there the artifacts will be distributed to Artifactory Edge servers, which are your endpoints inside your organizational network to get the updates that are deployed from Artifactory through JFrog Distribution. So this is a very, very big picture. Today we're going to talk about only two aspects of all that, and that will be JFrog Artifactory and JFrog X-Ray. We have a very similar environment to what you are going to see today, which is more broad, which also includes JFrog Distribution and JFrog Edge servers, but that's probably a topic for another webinar. And in the end of today, I will actually ask you what would you like to see next, and if that's something that of interest of you, definitely I will be more than happy to do a similar webinar talking about different aspects of this big picture. So just to kind of concentrate on one of the steps, you remember we spoke about continuous integration pipelines and continuous delivery pipelines, where the artifacts are promoted through quality gates. And this is kind of explains this concept. So you have the CI server, which builds artifacts from software, and then we have packages that are promoted through quality gates from one repository to another and being deployed to the consecutive environment for each and every step. And this environment is limited to see only the artifacts in the respected repositories, because those quality gates assuring that no inappropriate artifact will be visible to any environment in any time. So couple of words about X-Ray. So X-Ray is a universal artifact analysis tool. As you can see here, it sits on top of Artifactory, and it analyzes the artifacts from Artifactory, and then it provides metadata about those artifacts to Artifactory. And the analysis comes in terms of realization of the component tree. We know that most of the components in software are actually archives of another components, and we go recursively and unpack them through all the different package types that we support. So there is a Docker image, and inside there is a Debian package, and inside there is a Java war file, and inside there is a Java jar file. We will know how to get to all of them recursively and analyze the entire tree. Once we have this tree, we can ask questions about it using our internal metadata sources or external metadata sources. We can ask for questions: are there any security vulnerabilities, or are there any incomplete licenses, or what is the latest version that I have of a certain artifact? And of course, additional questions can be asked using external metadata sources. So think about the profiler that you can connect to your system, and then again report this metadata about artifacts. And maybe you found some kind of component which doesn't perform good, and you want now to do impact analysis and ask what are all the impact of this component. It's a part of other components that I need to be aware of, etc., etc. And of course, we are going to see all of that in action right now. So with that, I expect you now to have a running environment, and let's see what actually happened. I'm sorry. What you expect to see is an environment which is similar. Where is my here? An environment which is similar to this one. So you see a little log here, and you see some outputs which give you a username, a password, and a set of 3 URLs, one for Artifactory, the other for X-Ray, and the third one for Jenkins. Before we start using it, we need to unify the IP with the host name, which is hard-coded in our source and configuration files. And with that, what you need to do is you need to reconfigure the IP and match it to the host file. So what you have is this kind of environment. So you see here you have 2 Artifactory instances which run in highly available mode, and they are exposed in the port 80, and that's kind of the entry point. There is an X-Ray environment that connected to that on port 8000, and there is another Jenkins server that we will use on port 8080. So those are the 3 URLs that you see: one on port 80 for Artifactory HA config, X-Ray, and Jenkins. Before we go, and yes, and inside in Jenkins, you will see you will see 3 pipelines, and the first of them will be an application war file creation, and that would be a Gradle build that builds the Java file, and then a Gradle build that unit tests this Java file, and a deploy stage that deploys everything to JFrog Artifactory, and then a JFrog X-Ray that kicks in and does the scanning. Another pipeline is creating of a Docker base image. So we take a version of Ubuntu from an official Docker hub. We customize it by adding Java and Tomcat to it, and then we deploy this file again to Artifactory and scan it with X-Ray. And the third pipeline is the Docker application pipeline, which takes our customized base image, our Docker framework, add the war file from the Java pipeline, test it with the latest Gradle release artifact, deploy it to Artifactory, scan it with X-ray, and then run a test on this new container. Once all the tests are passed, this new Docker image is promoted to release and is ready to be run on your production environment. The Docker application, so this is how it works in kind of a more graphical way. You can see here that Jenkins does the build, and then once the build is over, this build is uploaded to Artifactory, and then Jenkins instructs Artifactory to initiate an X-ray scan. So Artifactory asks X-ray to scan the build, and X-ray scans the build, and once something happened, it generates an alert that can fail the build job in Jenkins, and then the job is failed, and we get a failed build in Jenkins. So let's start working on it, and on the trial run screen, you will see the documentation. The documentation, you can read it online or download, and your documentation here will be, you see there is a view and a download, and you have also the environment log, as I mentioned, with the IP and the password. As I mentioned, we need to change, we need to map this IP to a host name that we have hard-coded in our configuration files, and the host name that we use is JFrog local. So you need to edit your etc host files. For Mac, it is at /etc hosts. For Windows, it's inside Windows System 32 drivers etc host, and then you need to match your trial IP to JFrog local. And I will show you how it looks on my machine. So this is my host file, and I just did that. So I matched the IP that I get in my output environment log 32.225.56.87 to JFrog local. Please note that in order to edit those files, both on Mac and Windows, you will need an elevated access, root on Mac, administrator on Windows. And once you map this, you can actually go and use the ports that you have in your output, but instead of using the IP, you will use JFrog local. So for example, Artifactory Enterprise is on port 80, so you don't need to specify any port. And in Artifactory, then you just go to JFrog local, just like that. And our Nginx will navigate you to Artifactory home screen. You'll be able to log in using the username admin and the password that, again, you see on your test drive output. So here you can see mine. Am I on the right Wi-Fi? It's kind of slow. Yes. So that's my password and the username and admin. I can log into Artifactory and see that it works. Using port 8080, I can log into my Jenkins, and using port 8000, I can log in to my X-ray. So that's kind of the preparation step, and then once you have this JFrog local, you can actually start exploring the demo, and that's exactly what we are going to do. So let's start with Jenkins and let's see what we are building. So as I mentioned, we have 3 pipelines, and let's look at all 3 of them. We will start with the war file pipeline, and this is where we build our Java application. So let's wait for it to open, and let's go to the configuration and see what's going on. So what we are doing here is we use a pipeline script. You will usually use, obviously, GitHub to version and maintain the script. But for just the sake of the example, we paste this script right here. I will copy it to a proper code editor in order for you to see it more easily. And then we can actually take a look on it and see what's going on. So close the Explorer here. So what you can see here is that we use Jenkins Artifactory plugin that provides extensions to Jenkins DSL, and you can see here objects like Artifactory, from which you can set a server ID, and the Gradle instance that we are going to run is also get from this Artifactory factory. And then we have the stage of build. In the stage of build, we are checking out the code from GitHub and then configure Artifactory. We will use Gradle provided by our Artifactory plugin. We will provide the deployer where to deploy the artifacts, to which repository in which server, and to the resolver which repository use to resolve the artifacts on each server. And then we will add properties that will be attached to the artifacts once the artifacts are uploaded. So if this build is successful, it means that unit test passed, and that means that we can, once we upload the artifacts, we can attach the flag unit test passed, the properties unit test passed, to our artifacts if artifacts will be uploaded. And then we initialize the build info, and that's exactly the object that will collect the information about the build, and we instruct it to capture environment variables. This is very important as well. And then we run our Gradle. There is an option of deleting Gradle caches if we need, and then we run the Gradle. So this Arti-Gradle is a wrapper of our plugin around the Gradle executable, and it will configure Gradle to both use the repositories that we need to get the artifacts from and to deploy the artifacts with, and also it will instruct a Gradle to collect all the metadata that we spoke about, which is very important, like stuff which artifacts are used and which dependencies are used and all that, and save it as a build info as well. So Gradle run, and the tasks are clean and Artifactory publish, and then the build info that we need to put all the collected information is the object build info that we just created. Once Gradle build is successful and created all the artifacts and run all the unit tests, then we will start publishing the build information. So we have published build info, the artifacts are already uploaded. Now we upload the build info metadata and scan and fire up X-ray scan. So we say we need to configure this build name and this build number, the one that we just uploaded with the build info. And for now, don't fail the build, just because we actually want to get to the next stage. Although there is nasty stuff in X-ray, that's by design, because I want to show you what X-ray does. Obviously, in your environment, probably you will have here a fail build set to true, which is, by the way, the default, so you don't even need to set it. And then I say, okay, X-ray scan, start scanning based on this configuration, and once we have the result, just print it out to the results of Jenkins. And if I will look at the Jenkins output for this build, so going back here, and looking at the output of this build. Let's go to console output, showing the full log. So you can see here all the commands that we instructed. Here's the checkout, and then the build is running. If you remember, we configured Gradle to retrieve artifacts from our JFrog local Artifactory server. So you can see here that all the dependencies are retrieved from there, and then eventually the artifacts are deployed to JFrog local as well. Once the artifacts are deployed, there is the step of deploying the build information. Here it is. The build info was deployed. It's build number 28. We're going to look at it in a second. And then we trigger the X-ray scan on build number 28. And there was an alert actually generated. And you can go from here and navigate to X-ray to see the alert. We will take a look at that obviously as well. And we have a summary of all the problems that are part of this alert, and there are a lot. And just to kind of heads up, it's all struts, vulnerabilities, and that's why there is a lot of stuff. So this was the war file. So we run this Gradle build, we create this war file, and everything is great. And now let's take a look at our other pipeline. The other pipeline will be create Docker image template. So again, let's take a look at the configuration and let's see what we are doing here. So again, that's a Gradle build. And again, it uses, sorry, not Gradle build, Jenkins build. And again, it uses Jenkins DSL. So I will paste it here and we will see what we do now. So again, we check out from Git, we configure Artifactory with new build info, capture environment variables, and now we start working on getting on building a Docker image. So before we build a Docker image, we need to download the dependencies that we use there, and the dependencies are, if you remember, a JDK and Tomcat. We will again obviously download them from Artifactory because this is where all the dependencies are, regardless of its Java or operating system, and we will use them using what we call a download spec. Download spec is a pattern-based language that specifies what needs to be downloaded. So we download files from Tomcat local repositories under Java JDK 8, and we will put them under a JDK library on the directory on our workspace. And the same, obviously, with Tomcat. Once this is done, just verify that file downloaded successfully, and now we can start and build our Docker image. So what we're going to do is we're going to run actually Docker build using a very simple Docker file that adds those two files to Docker image. And then after Docker build is successful, we're going to push it to Artifactory and eventually publish the build info as well. Before we can continue, we will test it by downloading to it the latest known WAR file and verify that everything works correctly. And we also will trigger an X-ray scan in the same manner that you saw previously. Once the tests are passed and the X-ray scan was successful, we will promote this Docker image from a dev repository that it was created into a promote repo, which is a next repository in our promotion pipeline. And this metadata will also be recorded in Artifactory we're going to look at it right now. So that's our second build, and and the third one is combining the two. So step 3 will be building a Docker image product, and again, looking at its configuration, we will expect there to download a WAR file and build a Docker image using our base as a from and adding the application file. So let's see if that's what we find here. Again, that's our script. And let's take a look. So we check out Git and create Artifactory and initialize the build info, and we create our Docker wrapper that will again do all the configuration around Artifactory and record build information. And then indeed we use this download pattern to find the latest WAR file, the latest Java output, and download it as a WAR web service.war, but only if it has those properties of unit test pass. It can be obviously any other filter that makes sense to you. After those files are downloaded, we are going to run a Docker build, and this Docker build actually adds this file to the base Docker image that we created and push it to Artifactory. And then we run some tests, and then we run XOR and if tests are good and XOR is good, we are promoting this repository in our pipeline. So that's more or less the setup, and obviously all those builds already run many times, so we can go to Artifactory and see the results of them in the build in the build section of Artifactory. So I'm going to log in using again the password that I have in my output of my test drive right here. And now I can go to my builds and look what's going on. So here is the build information that was collected. Remember, build number 28 from Java file. That's the first that we start. We see here how Gradle recorded the information about the build and deployed it to Artifactory. So you can see here all the artifacts. So here, that's, for example, a WAR file, and also we publish the POM and Ivy, and all of those dependencies are recorded. We also recorded environment variables. So you can see here that, for example, which Java version was used. JDK. Only build info. Yep. Here. To search here. Which Java version was used. So you can see here it was 1.8 update 181. And that is the version of Java that was installed on Jenkins during the build. And by the way, from here, you can actually get to the results of this build in Jenkins by using the URL on the agent. So we will get here directly to the results of this build, of build number 28. That's obviously the one that we looked at earlier. Another useful stuff here on the build browser, we can, for example, compare this build with previous one and see if there are any changes. So obviously we build a bunch of new jars, new XMLs, and POM files remain the same. And some dependencies, most of the dependencies didn't change. Some of them did change, but that's actually our internal dependencies. So they were supposed to be changed. Environment variables, also the build info, the environment variables, which are part of the build, changed as well, and others pretty much remain the same. So this is our first build. Our second build, what we expect to see here are the dependencies. If you remember, we downloaded Java and we downloaded Tomcat. They should be our dependencies, and our artifact should be the Docker image. So here are our dependencies, and yes, That's the Tomcat file and the JDK file. And you can see here that the artifacts are our Docker image with manifest.genset. We can go and look at this Docker image in a tree browser, and that's our build number 25. You can see here what we actually did. So what we did is running Tomcat, and you can see here how we added the two files that we added, and that was the Tomcat and Java, right? So this is how we built our Docker image. From here, we can go back to the build browser and see here how it was when it was created. That's the same build number 25, and from here you can go to Tomcat if you need, or you can drill down and see what we saw earlier. There is another interesting stuff that happened with this Docker image. If you remember, it was promoted after we run our tests and discovered that the X-ray scan and discovered that this Docker image can be promoted. We actually run a promotion and moved it through to Docker prod local, and added comment that everything went well. The user we used was Jenkins, and this is where it was promoted, right? So you can see the promotion history here in the build info as well. And the build info of our last step was, again, the dependency you know by now is the war file from the step number 1. And here it is, that's our war file. And the output is a new Docker image here that is our which is our product Docker image, in which, if you look at the Docker stack here, you will see that we actually run Tomcat now. And before we run Tomcat, we actually copied the war file into web apps swamp of war. That's the war file that we saw as a dependency. And again, manifest here knows how it was built, and in the build here we have our promotion recorded, and you can see that we moved this file upward with the latest release version of Gradle Swamp App, Tomcat, and JDK, and it was again promoted to Docker prod local from here. One thing that we didn't look is X-ray, so now would be a good time to look at X-ray. So again, using our environment log, we can see that X-ray is installed on port 8000. So we will go to JFrog local 8000, and here is our X-ray home screen. Let's see if we need to log in once again. No, okay, we're logged in, and you can see like the home screen with the vulnerabilities that are being constantly added to our X-ray. Well, let's see if we need to log in. No, we're good. And what you can see here is the recent violations, and that's actually the results of the latest latest scans. So you can see here there are some major, there are some minor, unknown. You can see like a big list. One Artifactory instant connected. We already scanned almost 2,000 artifacts, and we found like 2,000 violations from those artifacts. Well, that's really concerning. The way X-ray work is that you declare watches on different stuff in Artifactory. So if you can generate here a new watch, you can see here that the resources that you can watch are repositories or build or a specific or even every artifact in Artifactory. And then if you watch a repository, you will provide a repository name, and if you want to watch a build, you will provide a build name, And all this, of course, comes from Artifactory. So if you want to build, those are the builds that we just spoke about, and they're all listed here. Or if you want to watch all builds, there is nothing to configure, or every artifact, there is nothing to configure as well. Once you set up what you want to watch, you need to specify what you want to find. And this is defined in properties. So on a watch, you assign a property, in policies. So on a watch, you can assign policy, and we have different policies of security and licenses. So we can actually go to policies and create or see the policies that we want. So now we have 6 different policies declared. When you want to declare a new policy, you provide the name, and then you select whether it's security or license policy. And if it's, for example, a license policy, then you provide a rule of allowed licenses or banned licenses. So, for example, let's create a rule: no GPL, and banned licenses will be, it should be no GPL. And then from banned licenses, we will have a GPL license, which is not allowed to use. All the GPLs ones, we do not want them. So let's select all the GPLs. Well, etc., etc. You kind of got the gist. There are a lot of GPL variants. So here we go. And right, so let's see what we did. GPL licenses, and it's a critical violation. We can select which level it is. It is critical, and we can decide if we want to block the download to the client, to the machines, to the CI servers of the artifacts which are banned by this rule, and whether the build should be failed as well. So the policy will be no GPL as well, and we created a policy, and now let's create a watch using this policy. So the watch will be on every artifact in our Artifactory, and the policy will be no GPL, and the watch will be called no GPL as well. So once we create that, we can actually calculate and see if we have any violations. Well, there were no violations because obviously we didn't have any GPL dependencies in our Artifactory. But we do have other violations here, and we can go to our home screen and take a look at them, and you will find a lot of violations right here. So let's take any other of them and drill down and see what violation is and how it looks. So here is an example. We have a critical violation that we can go to a component that is affected by it, or go to the watch that created it. So let's go to the watch, and let's create for, or just let's take a look of all of them. So it will load all the violations, and as you remember, there is a lot because of this struts thing that kind of spread through our entire application. It really shouldn't take that long. Yeah, okay, so we can do it another way. We can calculate it from here, and now you can see that there are a lot of violations here, and we can see that's the policies. All right, and we can see the violations in this in this watch. So let's look at one of the critical violations, and we can clear here on a summary of this violation and see what happened. So you can see that we do have a security problem here, and its severity is critical. And we can see here that what actually happened is that we have struts a vulnerable struts component inside our war file, inside the Docker layer, inside the Docker image, inside our Docker build. Now, this, if you can look at it, that's pretty extraordinary, because this swampUp war file is our own absolutely proprietary file. And most of the security solutions out there will stop there and will say, well, that's an application file. We don't know if it's vulnerable or not, and we'll probably kind of green this build. But we know how to deep into each and every component recursively and find all the violations down to a complete breakdown of all the components. And this is what we actually saw here. So from here, we can go, for example, the component of this struts file and look how an impact analysis work. So let's see. Let's say you heard about this struts thing over the news, Equifax and what's not, and now you want to understand if you have this struts, horrible struts component in one of your production environments. So you can take a look at the component here, see all the violations that you have, and then you can start ask questions about this component. So you can say, okay, I want to understand if I have any ancestors, if I have this component inside any other component graph. And you can see here, whoa, there are a lot of files that include this component. But maybe those files are not really part of any product. So we can open any one of them and see that, okay, this war file is actually inside a Docker layer. But maybe that's not bad, because this Docker layer is just orphan and not a part of any Docker image. So you can dive in and say, well, okay, it is a part of Docker image. But now the question is, where is this Docker image? Maybe we did the scanning and kind of stopped the build and never promoted this Docker image to production, and then we are safe. For that, we can go and take a look at this component image and see where it is located. And if you look at that, you'll see that, well, it wasn't staging in one day, but then it was actually promoted to production. And that's because, if you remember, we didn't fail the build on the results of the X-ray scan. So it actually went to production in our in one of our Artifactory from one of our Artifactory instances. And you can go from here and, of course, get to Artifactory and see where this Docker image is. And from here, from looking at this Docker image, you can actually see how it was built. It will take a second to load. Here we go. So now from here, you can see how it was built. It wasn't recorded. That's an old one. But yeah, if we will take one of the latest ones, like this one, you can see how it was built, and then you can actually go to Jenkins and see the configuration and probably discover the root of the problem. And the root of the problem would obviously be that although we scanned this image with the X-ray scan, as you all remember, we had this flag of right here, fail build was set to false, and this is how a Docker image with these horrible vulnerabilities actually made its way to promotion and made its way to production. So with that, I would like to finish with a couple of more words. So the environment that you have is now live for 4 days, and you can play with it, do whatever I did, or mess with it in any way you like, delete files, add your own files, build your own pipelines, whatever you feel like doing it. And once you had enough of it and kind of got the gist of how everything works, next step will be a real trial that you get from JFrog.com. You will get an empty environment that you will start adapting to your use case and not the synthetic demo environment. And of course, with your setup, with your data, you will end up with something that you want to stick around after you finish the trial and go into production with it. And that's the difference between this test drive and the real trial. So it's a good time to ask some questions in the Q&A tab. As I mentioned, there are a couple of there that I will get to in a second. And while I'm going into answering your questions, there is a question that I want to ask you as well, and that would be, what would you like to see next? So I'm going to launch a new poll, and that would be what I want to hear about the most in future JFrog webinars. And if you want something more like that, or you want like more structured presentation about using JFrog products, maybe partner webinars and integrations. You saw some of the integrations today, but obviously that wasn't the main focus. Or if you want an overview of new products and features. And now I do have a couple of questions. So here, the first question is where X-Ray gets the list of vulnerabilities and how often it is updated. So I actually briefly show you this list on the diagram that I showed. I will just get back to it real quick. So here you can see that X-Ray is connected to a list of external data sources, and you can see here stuff like National Vulnerability Database, open databases of vulnerabilities from Debian, Ubuntu, and Red Hat, and also a database of vulnerabilities from a company called Snyk, one of the partners that we will be glad to talk about if you want to see more partner webinars. And the public database of JFrog is being updated every 24 hours. So if you go to X-Ray, you can see here that I actually had it in the middle of update last time I went to it. So let's see what's going on now. Yeah, you see that the database sync is running, 1 hour remained, and this is exactly the process in which X-Ray goes outside and downloads the vulnerabilities. Yeah, so the other question is this promotion is a part of the distribution that I talked about? Well, not yet. So there are the promotion pipeline that we saw now, and again, going back to my slides, is more of like that. So you see here how we promote artifacts from one through quality gates from one to another. So this is what we saw. We saw those Docker images moving from staging to production once the tests are performed and the X-ray scan is completed. The distribution that I refer here to Bintray as a public distribution and JFrog distribution as an in-house or corporate distribution, those are what happened to the software after they reach the end quality, the end of the pipeline. Then it actually goes to those distribution pipelines, which take the ready software that we declare as ready and ready to production and send it to the end destinations. So with that, we're out of time. Thank you very much for participating. Thank you very much for your feedback, for your questions. I hope you will like what you will see once you play with your trial run. Again, if you ended up not starting yours and just following slides, that is fine as well. And that means that now it will be a good time to go to try.jfrog.com and start your trial. If you have this, feel free to play with it, and of course ping us if you have any questions. There is contact us button right in your trial logs, and you also got an email about it. So with that, I hope you enjoy your trial run. Thank you very much, and see you in the future webinars of JFrog.